you're going to use for all of these. And it's an easy formula to work with. And it says that percent yield, so if it's going to be a percent, it's going to be multiplied by 100. You're going to take the actual yield and you're going to divide it by the theoretical yield times 100. Okay? So, in a problem, you're going to be given one of these three. One of them you can always figure out. Which one of these things can you always figure out, do you think? I mean, you can always figure out without knowing the other two. The theoretical. You can always figure out the theoretical. So guess what? Every single problem, you're going to find the theoretical yield, no matter what. You say, well, I don't know where to start. Start by finding the theoretical yield. You find the theoretical yield, you'll be able to solve your problem. Okay? Because everything is based upon the best. It's kind of like if I give a test and I say, hey, you got 54 points. Yeah. What does that mean? Well, I don't know, you got 54 points. Well, how many points was it out of? Well, you don't even know that. It's 54 points. Okay? It could be 54 out of 55. It could be 54 out of 100. Okay? What do I need to know to find the percent? How many points it's worth. You always got to find the theoretical yield. Does that make sense? Everybody knows how to find a theoretical yield in here. It's a mass-to-mass problem. You're doing it on your lab. You did it on the assignment. Everybody can do that step. So if you don't know where to start, then that's what you start with. So let's go ahead and do that. Let's find the percent yield. Now, the other one we're going to have to be given in the problem. So what are we given in the problem that we can plug into our equation right away? We're given 40 grams of aluminum oxide. Okay? So we're given 40 grams of this. What is that? Is that a theoretical yield or an actual yield? Actual. Okay? So we know the actual. Now we just have to find a theoretical and plug our numbers in, right? Sure. That's all we have to do. So I'm going to let you guys do this, and we'll see what you get for theoretical yield. This will be good practice for you, especially on the last assignment. You did the last 2 or 3 problems were mass to mass. This is kind of give you a good idea if you're doing it right or not. Okay? So you have 25 grams of this stuff here. And you have to find the theoretical from that. Okay, I've given you the molar mass of aluminum oxide. So see what you can do with that.
Why is it 2 more Al3? No, why is it 2 more Al3?
4 to 2. 4 to 2. Okay? It's your ratio. We did this on every single problem since the beginning of these problems. We've always done mole-to-mole ratios. You have to go through mole-to-mole ratios from one substance to another. That's never changed at any point in this chapter. Chapter 9, mole-to-mole we started with. So every single calculation you do has to be done as a mole-to-mole. Okay? I come up with a different answer, so I might have did my calculation wrong at the beginning. I'm going to check it again. Okay, my answer was right. 47.2 grams. Okay, and that's a theoretical yield, right?
Wait, don't you put 1 mole of Al2O3 first and then 2 in the bottom?
Here? No. Yep.
Wouldn't the label be AL2?
Yeah, it would be Al2O3. Sorry. Yep. Guys, this is what we've been doing. We've been practicing. If you're not getting this mole-to-mole ratio right, anytime you do mole-to-mole ratios, you have to look at your balanced equation. This first step and last step are just grams to moles. That's all they are. Grams to 1 mole to so many grams. That is the way to do it, guys. I'm canceling out my units as I go. I can copy them as I go. Okay? So then when you put that in to your calculation, you're going to get 84.7%. Is that what you guys got? 84.7%. Because the 40 grams go in here. The actual yield, this is your theoretical yield, then you times it by 100. So that's what you get.
So the answer for the theoretical yield is 47.2.
Yes. 47.2. Okay? Any questions you have on that?
Did I say 101?
9.6. Okay. I'm recording this. If you want to copy this out later on, I'm gonna move on to the second type. Again, every time you do a problem, you're going to have to do a theoretical yield. So when I show you the second one, you automatically got to do one of these steps where you go through those 3 steps to find your theoretical yield. So we're going to look at the problem. I got to give the equation to it here, but I'll give you a little time to write this out, and then I'll write the equation down here. And I'll move out of your way once I write this in. So, as you're writing this in, you guys get one more chance to see if you can set up to find the mass of a certain product. And it's a mass to mass, and you're finding a theoretical yield. Okay? The Fe2O3, I'll give you the molar mass up here, so you don't have to mess around figuring that out. Everybody can find molar masses. So I'm not going to have you... When we do the test, too, there'll be some questions. I will give you the molar weights so you don't have to find them and waste time doing that. You can show me you know how to do it without having to find a molar mass. So that's definitely what I'm going to do on the test at times. Okay, so we know our equation is percent yield is equal to the actual divided by the theoretical times 100. Okay, so we already know that. So we're given a percent yield is 81%. So we can plug that in right here, 81%. Okay. On this one, we don't know the actual yield. We're asked to solve for this. So we're solving for the actual yield. But we can find the theoretical. And then we can rearrange your equation to solve for it. So, go ahead, use that equation, and the 250 grams of Fe2O3 to solve for grams of iron. That's what you're looking for here, iron product. So go ahead and do a mass to mass and see what you come up with. I'm going to give you is the answer to the theoretical. I'm going to tell you theoretically how much could have been produced. And the theoretical is 174.87. 174.87. I'll show you the set.
So what was that? So when we were doing the max to max,
Yep.
what was that answer?
174.87. That's the answer. So, if you didn't get that, 250 grams of Fe2O3, grams to moles. So, there's 159.69 grams of Fe2O3 for every 1 mole. Fe2O3. Then we use our balanced equation. It says for 1 mole of Fe2O3, we have 2 moles of iron. And then for every 1 mole of iron, we have 55.85 grams. Okay? And then, so I cancel out grams of iron oxide, moles of iron. Now I got grams of iron. And when I do that,
Wait, how can what?
which one are you worried about? What step?
How come you put the 159?
Because I got to get it into moles.
Yeah, but I thought you put that in the last column. That's what you did last time. I thought the first.
That depends upon what my product is. My product, it says it's iron, so I need to find grams of iron produced. So that's what goes on the last line, is I've got to find grams of iron.
How do you know? Like I put in the third column, I put 1 mole over 2 moles. How do you
Here?
know? Yeah, how do you know like which
This
one?
tells me this moles of Fe2O3, I need to write moles of Fe2O3, and then when I look at my equation, there's a 1 in front of it. And when I look at iron, there's a 2 in front of it. So that's why I put a 1 there and 2. Yep.
So, we found our actual yield, right?
Nope. This is always theoretical. This is 100%.
Okay.
Okay, this isn't the final answer yet. So now I plug that in here. 174.87. It's a 80% yield.
81.
Or 81. Okay, so 174.87. Actual. So what I'm going to do is I'm going to make this the decimal form, so it's going to be 0.81 equals that, and I take out the 100. I divide both sides by 100. So 81% divided by 100 is 0.81. I divide that whole side by 100, then it's just this. So then 0.81 times 174.87 gives me my actual.
141.
Yep. So the answer is 141.6 grams of iron. Okay? So, this is due on Monday. Okay? And I'm going to give you 4 of these to do. And so you've got 4 days to do 4 problems. Right? Is that how that works out? Okay? So,
Do these in our notes?
yep, do these in your notes. Okay, you can check answers on 2 of them. Okay, so you can check answers on 2 of them. 27A,
Theoretically,
page 265. So it's going to be 27A. We'll do 28A. Can't check your answer on that one.
you gotta go.
Um,
You gotta go one mole every two over to
So I just had to take it from 2 days.
Yeah, much.
29A and 30A. So 27 through 30 A's. You can check your answers on these two as you go through. Okay? Remember, your lab is due sometime tomorrow. I mean, it could be midnight tomorrow. I don't care. Okay? Make sure you guys are doing your own work. There's a tendency for people to get panicked and start copying other people's stuff. Copy and paste. I'm going to check it. Okay? So make sure you're doing your own stuff. This is an assignment basically over the weekend because you can't do anything with the lab. We're not going to be able to do anything with the lab over the weekend or anything like that. And then I'll get you guys a review tomorrow because we went through all the type of problems already. Okay, so next Thursday, the plan is for a test. So you should know everything that's going to be on the test right now. You just have to practice some of this latter part.
If we didn't have
Yep.
today's assignment done, can we turn it in tomorrow?
Well, all I'm going to do is put in the grade book it's missing, and it stays missing until you turn it in. You got 2 days.
Did you want that on a separate sheet of paper, or can I just do it on?
You can do that in your notes.
Okay.
Do it on a separate sheet of paper.